All right, let's talk about exponential decay. Remember, an exponential function, the basic form is y equals a times b to the power of x. You might often see a t here instead of an x. It just means that we're using unit of time instead of like a traditional x thing. And today we're going to focus on functions that move towards the asymptote as you move left to right. So that could look like this, or it could look like this. And I don't know why I have 3 here. Maybe there's another way it could look, but really these 2 are the main that I'm talking about. And why does this matter? What do we use exponential decay for? Lots of things that use exponential decay. Anytime you have something in value that goes down over time, like an automobile or any type of technology, usually like a computer, an iPad, an iPhone, all of those things decay in value. So that's exponential decay. You also have exponential decay when it comes to like radioactive substances. A substance has so much radioactivity and that decreases slowly over time. We also have exponential decay when it comes to like a drug that's in your bloodstream. So if you took some medicine, it's going to be in your bloodstream. It's going to start off really high, and then slowly your blood is going to filter that out, and it'll decay and drop down. So those are all types of decay like this. Okay, so I want you to maybe pause and just list a couple of examples of real world that you think exponential decay would apply to. Okay, hopefully you got a couple of those. Let's move on. So how do you know if it represents exponential growth or exponential decay? Well, it's actually pretty simple. It's exponential growth if the b is greater than 1, and it's exponential decay if the b is between 0 and 1. So if it's some type of fraction between 0 and 1. So on these ones, identify the following functions as exponential growth or decay. I'm just going to put a g or a d. Well, here the b value is greater than 1, so we know that that is growth. Here the b value is between 0 and 1, so we know that's decay. All right, I want you to do the last 4 on your own, see if you could figure out whether they are growth or decay. Go ahead and try that and check back with me to check your work. Okay, there you go. There's your answers. This one might have been tricky because you might have seen a fraction and thought, oh, it's a fraction, it counts as decay, but really 5/4 is bigger than 1, so that's really growth. All right, let's talk about graphing an example, one of these questions. And I want to like do a little throwback. Remember that we already knew that we get these free points when it's in this form. We always get 0, a and 1, a times b. So we already get these free bits of information. So let's go ahead and just put that on my little t-chart. I know what 0 is going to be my a value. My a value is 3, so I have that. And I know 1 is going to be a times b. 3 times 3/4 is 9/4, or you could say 4 and 1/4. Okay, what's the domain? Domain, remember, that's the x values. Well, there's no x value that I cannot plug in here. So this is all real numbers. Or another way you could say that is all the numbers from negative infinity to positive infinity. All right, the range. What are we talking about for y values? Well, I think this one might make a little bit more sense if you see the sketch of this. But here's a basic thing. Is there any way to make this value negative by plugging different values in for x? So if you plug in a really big number, like a million, all that's going to happen is that this 3/4 of the million is going to get really, really small, but it's not going to get less than 0. And then we're going to multiply that by 3. So we'll get a really tiny number, but we will not get a negative number. And if I make the x value negative, it also doesn't become negative. Let's think about what happens. Let's actually plug in a -1 and see what would happen. I'm going to do the work down here. So what's y of -1? Well, it would be 3 to the 3/4 to the -1. And remember what a negative exponent does. A negative exponent to a fraction just flips the fraction. So this is really like saying 3 times 4/3. And the 3's can cancel out, and you get 4. So at -1, you get 4. So actually, because this is a fraction, because we're dealing with exponential decay, as we get negative exponents, these numbers get bigger and bigger and bigger. So the range is going to be all values, all y values that are not less than, sorry, all y values that are greater than 0. Another way you could write that is all values from 0 to positive infinity. All right, so what I like to do is plot these points here. All right, these are all just points, and that helps us get an idea of where this thing should be. So negative 1, 4, 0, 3, and at 1, we're at 2 1/4. And we could probably get more out of this if we really wanted to and get more points, but I think I have enough to get an idea of what this thing looks like. Remember, it's going to approach the asymptote of y equals 0, so I'm guessing it looks something like that. That's a good enough sketch. But if you wanted to plug in a 2 or a 3 and so on, you could get some more accurate points. I have a feeling they'd be a lot of fractions, so I don't think it'd really help you all that much anyway, but you can get some points here. All right, let's go to the next page. All right, so I wanted to point out that -1 point because we actually get something out of that, that we get a free point out of that. So let's talk about that. Let's say over here I have y equals ab to the -1, right? So what I want to do is I'm going to say, let's say I was to plug in a -1 for x. What, in terms of a and b, what will I always get out? Well, remember, -1 just means you flip. So this would only apply to the b. So you could think of this as 1 over b. And when you multiply a fraction times the whole number just goes on top. So you get a over b. It turns out that when you plug in a -1 in this format, you're always going to get a over b. So I want you to, I don't know why this didn't print, but I want you to graph this function now that we have it, -2 to the 1/4 x. And what I want you to do is use these 3 points. I'll walk through this one with you guys. But remember, we know that if we can now get -1, 0, and 1 really easily, right? So -1 is just a divided by b. Well, there's my a, it's -2. But if I divide by 1/4, think about what that is. I'm going to kind of work that out. -2 divided by 1/4. When you divide by a fraction, that's the same thing as multiplying by its reciprocal. So that's really -8. Okay, when I plug in a 0 up here, right, I just get whatever my a is. So that's just -2. And when I plug in a 1, I get a times b. So -2 times 1/4 is -2/4 or -1/2. All right. I can plot these points, and I get a pretty good idea of this graph. So these are just points. -1, -8, that's a little bit off my graph because my graph only goes to -6. So here's -8. And so we'll say my first point's about here. And then at 0, I'm at -2. And at 1, I'm at -1/2. And we can get an idea of what's happening here. Something like that. Okay, there's the base function here. But what happens if I try to translate it or shift it? So remember, the h and the k just shift it vertically, or the h units shift it horizontally, and the k units shift it vertically. So what does that mean? Well, I'm going to use these numbers from what I would call like the parent function or the mother function of this one. See how they're really similar? This one doesn't have an h or a k. So I'm going to find these values first, and then I'm going to shift them accordingly. If we look here, we know that my h is +1 and my k is +3. If you're not sure why that is, remember the h is always the opposite of how it looks. H is negative. It looks like -1, but that's really just because there's a minus there in front of the h. So what does that mean? That means horizontally we're going to shift +1 and vertically we're going to shift +3. So you could kind of just take these values and add 1 to it in the x category and add 3 to it in the y category. Let me show you what I mean. So for this first point, I'm going to add 1 to the x value. Well, if I add 1 to -1, that becomes 0. And if I add 3 to the -8, that becomes -5. All right, how about for this next point? If I add 1 to the x, it becomes 1. And if I add 3 to the y, it becomes +1. And then lastly, we'll do this one in green. If I add 1 to the +1, I get 2. And if I add 3 to the -1/2, I get +2.5. All right, so those are my core points after I shift them. So when you get a weird function like this, a good strategy is to find your core points of the mother function and then just shift them by these amounts, by whatever your h and k are. So let's graph this thing. 0, -5, that's about right here. 1, 1, that's here. And 2, 2.5 is right here. And remember, the k value is also your asymptote. So I have an asymptote right here now. Before, on the mother function, the asymptote is always just y = 0. But this one, the k value changed, so it shifts up. So when I go to graph this thing, it's going to look something like that. And there's my graph. Okay. Let's move on. Let's talk about percent increase and percent decrease. So if it's a percent increase, you're going to think of that b value. All of this is the b, but you're going to think of it as 1 plus r. If it's decrease, you can think of it as 1 minus r. I'll explain what I mean by this in a little bit, but the r is how we can interpret it as a percentage. So the a, that's the initial amount or the starting amount. And r is your percent increase or decrease. And t, this is usually given a time unit. And this is like your input, so it's like your x. You can say, I'm just going to kind of like your x. So let's give the percent increase or decrease for the following problems. Well, on this one, your b is 3, but remember, you need to break it up as 1 plus something or 1 minus something to figure out what your r is. So if I was to write 3 as 1 plus something, it would actually be 1 plus 2. So 2 is your r. So r equals 2. Therefore, as a percentage, we would say that because it's like 2.0, you're going to move that decimal over 2 spots. And so we would say this is a 200% increase. For number 5, we have to figure out how we could rewrite that, I'll do it in red this time, as 1 plus r. Or 1 minus something. And so what would we have to do? What would we have to subtract from 1 to get down to 0.925? Well, it would be minus 0.075. So your r is negative 0.075, which as a percentage, we could say negative 7.5%, because if I move that over 2 spots, I'd be at 7.5. So that one is decreasing, negative 7.5%. So you could also say it's decreasing by 7.5%. All right, I'm going to make up these last 2 problems. I want you to try these on your own. They're going to be very similar, but slightly different. What if I had 100 times 1/2 to the x? And over here, what if I had 100 times 1.5 to the x? Think about what your r value would have to be. Is the r positive or negative? And is it decreasing or increasing? Go ahead and try those 2, and then check back when you're ready to check your work. All right, so right here I got 1/2. I got to think, how could I write that as 1 plus or minus something? Well, we could write it as 1 minus 1/2, and that would be 1/2. And so therefore, I think of 1/2 as 0.5. So my r is really negative 0.5. Or I could think of it as negative 50%, which means it's decreasing by 50%. Over here, I can think of it as 1 plus positive 0.5. Therefore, my r is 0.5 or 50%. And we could say it's increasing by 50%. There you go. All right. See you guys in the next video.